Welcome again. The statistical measures that we used earlier for the detection of univariate outliers, that is noise values, were not doing very good. So consider this as a bonus lecture on the topic where we are going to discuss a couple of more ranges of normality to detect noise values or univariate outliers. So one such approach is to have the range of normality defined as mean minus 3 times standard deviation as the lower limit and mean plus 3 times standard deviation as the upper limit. Instead of these 3, other values like 2, 2.5, 3.5 can also be tried. So if we get back to the previous slide, over here we defined the range of normality as minus 3 times sigma into mu as the lower limit and 3 times sigma into mu as the upper limit, which were giving us quite a big range and wasn't making much of a sense. So if we take these values from here, which is mu or mean equal to 618 and sigma or standard deviation as 1503. So using these values, we can also define the range of normality using this approach as mean, which is 618 minus 3 times standard deviation, which is 1503. This would be the lower limit, and the upper limit is going to be 618 plus 3 times 1503. So if we resolve this, we are going to get minus 3,891 is the lower limit, and the upper limit is going to be 5,127. Now, as we can see, this value is still not being detected as an outlier, but in comparison to the previous range of normality, this does make a lot more sense and is much closer to the values as compared to the previous case. Another way of defining such range of normality is to use the interquartile range method. According to this method, we have to define the interquartile range, that is the range between the 75th and the 25th percentile of the data. So first we'll have to calculate the 50th percentile, and then using that we'll have to define the 75th and 25th percentile, subtract 25th percentile from the 75th percentile, and that is going to give us our interquartile range. And then using the lower and upper cutoff on the interquartile range, we can define the range of normality. So let's just do that for the attribute items. So first we'll have to arrange the numbers into order. So we will have 2, 3, 4, 4, 5, 6, and 4300. So the numbers are being arranged in increasing order. So next we'll have to pick the 50th percentile, and that is a value that has 50% of the data above it and 50% of the data below it. So in this case, if we pick the middle value, this is going to be our 50th percentile, having half the points below it and the other half above it. Our percentile 50 is going to be the value 4. So next we'll have to pick the percentile 25, and that is going to be the middle value of this half, or the point that is above 25% of all the points. So the 25 percentile over here is going to be the value 3. So the percentile 25 is the value 3, and the same way the 75 percentile is the one that is going to be above 75% of all the values and is going to be the middle value on this half. So that is going to give us a value of 6. So P75 is going to be 6. Now with this we can define the interquartile range is 6 minus 3 that is going to give us a value of 3. Next we need to define the value of k, and generally a value between 1 and 4 can be used for this parameter. So over here it's being called as k. So let's say we use the same value, that is k equal to 3. So using the value of k equal to 3, we can define cutoff is equal to into k, and that is going to give us a value of 9 because the IQR have got a value of 3 and we have also decided k to be 3. So the cutoff value is going to be 9. Now using this interquartile range value and the cutoff, we can define the range of normality as IQR minus cutoff to IQR plus cutoff, and that is going to give us a range of 3 minus 9, that is minus 6, to 3 plus 9, that is 12. And this does make a lot more sense for the items column, and now this is going to be detected as an outlier. The same we can do for the price column also, and I believe it's most probably going to detect this one as an outlier as well. So I'll just repeat what we have done over here is that we have arranged all the numbers of that particular feature in order, and then we picked the middle value that we called the 50th percentile. Then we picked the mid value from the first half that we called 25th percentile, and picked the mid value in the second half and called it the 75th percentile. Next we subtracted the 25th percentile from the 75th percentile and we called it the interquartile range. Then we decided a value of k and multiplied it with the interquartile range to give us a value of cutoff. Then the cutoff value is subtracted and added to the interquartile range to give us the upper and lower limit for the range of normality. So that is how interquartile range can be used and is going to be much more effective than the other statistical measures that we saw in this module.